Welcome to error bounds in numerical integration. So the idea here is when we use the trapezoidal rule or Simpsons rule, to approximate a definite integral from a to b of f of x dx, we expect to get an approximation, not the exact value. So the question becomes, how accurate is the approximation? It turns out there's some pretty quick formulas that we can use for kind of bounding what that expected error is. And we'll have a formula for trapezoidal rule and a formula for Simpsons rule. So for the trapezoidal rule error bound, let's go ahead and suppose that A sub t is the trapezoidal rule approximation. For the definite interval from a to b of f of x dx with n equally spaced subintervals. Let's let E sub t be the absolute value of a sub t minus definite integral from a to b of f of x dx. So this is the error in the approximation of the approximation. Then we have just one condition to be met. If it is met, then we can form our formula. So if the second derivative of f exists and is continuous, on AB, then it is a fact that that second derivative is bounded on AB. And so we're going to continue this if with, we'll say let M be a bound of the second derivative on AB So in other words, that second derivative, absolute value of the second derivative is less than or equal to m on AB. So by the boundedness theorem, if a function is continuous on a closed interval, it must be bounded. Then what we get is that the error E sub t is bounded by, or is less than or equal to, b minus a in parentheses cubed divided by 12n squared times that bound m. So this is a quick formula for bounding the error from the trapezoidal rule approximation. Next up, let's go ahead and look at the Simpsons rule. Error bound. So again, now we're going to suppose capital A sub x is the Simpsons rule approximation of definite integral from a to b of f of x dx with n equally spaced subintervals. Let's go ahead and let E sub s be the absolute value of a sub s minus the definite integral from a to b of f of x dx. So this is the error in the Simpsons rule approximation. Again, we have just one condition for f. This condition, if the fourth derivative of f exists and is continuous, on the closed interval AB. Right, so that means then the fourth derivative of f is bounded on AB. So we'll go ahead and let capital M be a bound of the fourth derivative of f on AB. Again, that just means that the absolute value of the fourth derivative of f is less than or equal to m on AB. Then we get that our error satisfies or is bounded by, we have capital E sub s is less than or equal to b minus a in parentheses, whole thing raised to the fifth, divided by 180 n to the fourth, that whole thing times n. So these are our two quick formulas for the error from the trapezoidal rule and Simpsons rule with n equally spaced subintervals. And the next video, we'll go ahead and do an example of each case.